The topic of the session, the chapter 5, is quadratic equations. The quadratic equations are also one of the most important concepts in mathematics as the linear equations. As we have discussed about linear equation is a linear polynomial equated to 0. Similarly, I can say a quadratic equation is a quadratic polynomial equated to 0. And then let's see how it has come into existence in mathematics. So for example, I had a rectangular plot whose area is 800 meters square. To start with, quadratic equations. Now, importance of quadratic equations is that we use this in many branches of other topics, even in science, where this is the most important concept. So let's see its origin. So for example, I have a rectangular plot whose area is 800 kilometers square, or I say it is 1600 meters square is the area of this rectangular plot. Then I know the length, but I have to adjust the width. Then let's see how we can do that using quadratic equations. So for example, a rectangular plot with area 1600 meters square is given to be with its length 4 times that of breadth, or I can say in addition to 4, it is added with 4 to that of width, so that when I take my width as x, then my length is x plus 4. If this is the minimum information given in a rectangular plot, then I can find the length and width using a quadratic equation. Then let's see how a quadratic equation is generated from this introductional problem. Now, as we know that the area of rectangle here is given to be 1600 meters square, then I next use the area of the rectangle, which is length times its width. So length being x plus 4 times of width being x would finally give me 1600 meters square, which in turn gives me x squared plus 4x minus 1600 equal to 0. So this is how I get when I take all the variables and all the constants to the left and only keeping 0 on the right hand side. Now, such equations which I obtain in mathematics for the given situational problem of a rectangular plot is called a quadratic equation. Quadratic because the highest degree is 2. So a quadratic polynomial, when I equate to 0, is on the whole called a quadratic equation. So we are going to study the different properties in quadratic equation in this session. So let's start with the basic definition of what is a quadratic equation in mathematical definition. A quadratic equation, what is it in mathematical definition? A quadratic equation, if we understand in the general form, it's a quadratic polynomial equated to 0. Of course, a quadratic polynomial in variable x, if I equate that to 0, then that equation is called a quadratic equation. And a quadratic polynomial is already discussed in the previous sessions, where a polynomial of degree 2 is said to be a quadratic polynomial. Now, if I take the quadratic polynomial in general form, then I assume the quadratic polynomial in general form as ax squared plus bx plus c equal to 0. This is called a quadratic equation in general form. And the condition here is that a is not equal to 0 and each of a, b, c are real numbers, and here x is the unknown, which is the variable. So the variable here is identified to be x. Is how I define the quadratic equation in X. This is the basic definition of quadratic equation in general form. Now, as we have seen that a linear equation has only one solution, then the quadratic equation has two solutions. A cubic equation has three solutions, so on and so forth. A polynomial of degree n has n solutions. Therefore, we always identify the two solutions for quadratic equation by using various properties, which we're going to discuss in the next sessions. So how to find the value of x is the next biggest question in this. How to find the unknown x? What are the different methods of finding x is what we're going to see, which is called finding of solution of quadratic equation. To start with an example for this is 2x squared minus 5x plus 6 equal to 0 is an example of a quadratic equation where the value of a is identified to be 2 because I compare this with the standard form of the quadratic equation, which is ax squared plus bx plus c equal to 0. Then b is minus 5 and c is 6 and the variable x is x. So this is clearly an example of a quadratic equation. But if I take 0x squared minus 5x plus 6, this is not a quadratic equation because this fails with this condition, a equal to 0. That implies not a quadratic. This cannot be a quadratic, is how I understand the quadratic equation with each of its basic definitions. So now that we have studied about quadratic equations, let's see where is quadratic equation applied in real life. Where do we use in the daily life is very important because we use this in various branches of science, especially physics. So applications of quadratics. Quadratic equations in daily life. Initially, if, for example, I take a person standing here on the ground, then he throws a ball onto this side, then the ball tries to go in this shape, then this is said to be a quadratic equation. Throwing of a ball or path of a projectile, this is called a projectile, which gives us a quadratic equation. So the first application is path of a projectile is a quadratic. Similarly, let's see, for example, I have, say, a rocket. Usually rockets go into the space from ground. Say I have a rocket which is out here, and once it is launched, then this tries to go straight into the sky, but we generally assume that it goes straight in the sky, but no, it doesn't go straight, but it goes in like this into the sky, and then it goes outside of sky everywhere, crossing the sky into the space, into the moon sometimes. Therefore, the launching of rocket, the moving of a rocket from the ground is also a quadratic, can also be represented using a quadratic, is one of the way of understanding the quadratics in real life. Also, there are many other applications. Say, for example, I take a vehicle. I have a vehicle, then when it is going very fast on the ground, then if I put the sudden brake, then the stopping distance is also a quadratic. The stopping distance of a vehicle is also a quadratic. Is representing a quadratic is how we understand the various applications of quadratics in real life. Even we have the reflecting mirror also one of the example of quadratic, because a reflecting mirror generally in the shape of a convex and plane on the other side is an example of a quadratic. Reflecting mirror also represents a quadratic equation. Similarly, the eyeglasses also sometimes, the contact lenses or the eyeglasses would also form the quadratic equation. When I take the glasses out here, this eyeglasses form a quadratic equation. Is how we see so many applications in branches of science in generally daily life connected to quadratic equations, which we are going to see in detail in the coming sessions. Now let's see how we can convert the word problem into the quadratic form, or representing the given situational word problem into the quadratic form. So for example, I have a problem which connects the right angled triangle with quadratics. So the question says, in a right angled triangle, the longest side is 25 centimeters and the difference of other two sides is 5 centimeters, then I had to find the other two sides, is the question. Then find the other two sides is the question out here. So this question is related to a right angled triangle. So let's draw a right angled triangle and see how quadratic equations can be utilized for this situational problem. So as the triangle here is right angled, so I take one of the angle as 90 and then draw a right angled triangle. Now also it is given that the longest side is 25. So obviously in a right angled triangle, hypotenuse is the longest side. Therefore, if I take the triangle as ABC, the right angled triangle ABC, then the longest side, which is the hypotenuse, would be a side opposite to 90 degrees, is 25 centimeters. BC is the hypotenuse, the longest side, and hence 25 centimeters. Also, it is given that the difference of other two sides is 5 centimeters. Therefore, if one of them, if I take it as x centimeters, then this would be x minus 5 centimeters. So the difference is 5. Therefore, one of them I take it as x plus 5 and one as x, because so that the difference of x plus 5 minus x would give me 5 centimeters. Is how I get the dimension. If one of them I take as x, the other would be x plus 5. The difference giving me 5 centimeters. Now with the dimensions of 25x and x plus 5, then I clearly use the Pythagoras theorem, the most important theorem connecting the right angled triangle with the sides, respective sides. Therefore, we know that by Pythagoras theorem, hypotenuse square is the sum of squares of other two sides. Therefore, hypotenuse square is the other two sides, which is AC square plus AB square. Therefore, this being hypotenuse as 25, I clearly get this as 25 square is AC, which is x square, plus AB, which is x plus 5 whole square. So let's see how a quadratic equation is generated from this Pythagoras condition. So if I simplify the right hand side, then this is a plus b whole square, which is a square plus 2ab plus b square, that equals 25 square. Further simplifying this, I get this to be x square plus x square, which is 2x square, then 2 times of 5, which is 10x, plus 25 equals 625, because 25 times 25 is 625, is how we get simplified statement. Continuing further, I get this to be 2x square plus 10x plus 25, and 625 I bring to the left, I get minus 625 coming to the left equal to 0. Now I just simplified this so that I get the simplified equation of this as 2x square plus 10x plus 25 minus 625 is negative times 600 equal to 0, is what I get. I can further simplify this by taking 2 common. Therefore, I get this as x square plus 5x minus 300, which is obtained by dividing 2 to each of the terms. The whole equation divided by 2 gives me x square plus 5x minus 300 equal to 0. Now this is said to be a quadratic equation in a variable x. This is a quadratic equation, and how to solve that? We have to solve this quadratic equation using the factors. So how do we find using the factors is the biggest question. So finding the factors for this, 300, I can write it as 20 times 15, which is 300, and 20 minus 15 is also 5. The factorization is already learnt in the lower classes. So as a recap, we had to factorize this, which gives me x square plus 20x minus 15x minus 300 equal to 0. So each of this as obtained from the factors of 300 as 20 times 15. Now let them be paired, pair 1 and pair 2, so that in pairs again I take something common. The possible things common out here is x with x plus 20, and here it is negative 15, which gives x plus 20 equals 0. So finally again I take x plus 20 common, which is the common factor in the first term and the second term. Therefore I get this as x plus 20 times x minus 15 equals 0, is how I get the factorization done. All the possible factors which are utilized to get the two factors. When the product of two factors is 0, each of the factor is assumed to be 0, such that implies factor 1 equal to 0 and factor 2 equal to 0. And then this gives me x equals negative 20 and x equals 15 is what we get. But I don't include this solution, but I include this because x is the length of the side, which cannot be negative. It should always be a positive value because length cannot be negative. The magnitude is always positive. Therefore, x is equal to 15, since x is the side and cannot be negative. Therefore, I get x equal to 15, but indirectly the question here is find the other two sides. I can find the sides. One of them is 15, the other is 15 plus 5. Therefore, AC is 15 centimeters, and my AB, which is x plus 5, is AB is x plus 5, which is 15 plus 5, which is 20 centimeters. So these are the other two sides of the right angle triangle. One side being 15 centimeters and the other side is 20 centimeters in a right angle triangle ABC, is how I understand the concept. So the solution which we have obtained in the previous problem of a right angle triangle was the solving of a quadratic equation by factorization. So this is purely an example of solving the given quadratic equation by factorization method, where we found the factors of 300 which have been 15 times of 20, and then we add or subtract to find the factors. So there are various methods of factorizing the given quadratic equation. So how do we find the factors of a given quadratic equation? What are the different methods is what we are going to discuss. But before this, if I give an example problem where I want to test whether the given problem is quadratic or not is very important before we solve the quadratic. Identifying the equation to be quadratic is more important before we find the solution of that quadratic equation. Say for example, I have an equation, say x squared plus 8x minus 11 is x minus 5 whole squared. Now I wanted to know if this equation is quadratic. So I need to simplify this, bring all variables and constants to the left and keep only 0 on the right. Until then, I cannot justify whether the given equation is quadratic or not a quadratic. So in this case, let me simplify this further so that I get x squared plus 8x minus 11 equals x minus 5 whole square is in the form of a minus b whole square. Therefore, this can be reduced as a squared minus 2ab plus b squared using a minus b whole square. To simplify further, I have this as x squared plus 8x minus 11 is x squared. This is 2 times of 5, which is 10. So minus 10x plus 5 squared, which is 25, is what we get. Now, as I see here, this x squared clearly gets cancelled, and then finally, when I bring all x and constants to the left, I get this as 8x minus 10x here becomes plus 10x minus 11, and plus 25 to the left is minus 25 equal to 0. This, on further simplification, gives 18x minus 26 equal to 0. Now, I say this is not a quadratic because there is no x square term. So this is not a quadratic, and hence even the given problem is also assumed not to be a quadratic, since no x square term exists. There's no x square term in the given equation. Therefore, this is not a quadratic equation, is how I understand the concept of quadratic equations. Now with this, once I identify that the given equation is quadratic, then the next task comes in how to find the solution of quadratic equations. The factorization method which is already dealt with. Now, how to find the solution of a quadratic equation, or initially to start with, what is the solution of a quadratic equation? What do you mean by solution of a quadratic equation? So let's start with the heading, solution of quadratic equation. So to start with the definition of solution, what is a solution of quadratic equation? It is the value of x which satisfies the quadratic equation. So solution is the value of x which satisfies the quadratic equation, is how we understand with the basic definition of solution. So we take the value of x, and when we substitute in the quadratic equation, it must equate to 0. Then we say that value of x is the solution of the given quadratic equation. So value of x which satisfies the quadratic equation is called the solution. Now, next coming to the values, these values of x are also called roots or zeros or solutions. So they have three different names. One is the roots, the zeros, or solutions. So when I say find the roots of the given quadratic equation is nothing but finding the values of x which satisfies the quadratic equation. If I say find the zeros of the quadratic equation, is nothing but finding the values of x which satisfy the quadratic equation. Or finding the solutions of the given quadratic equation is nothing but finding the values of x which satisfy the quadratic equation. So for example, if I take is this, then let me see the value of x which satisfies this equation, and that way x is either called the roots or the zeros or the solution. So clearly, let me start with the trial method. When I take x equal to 2, I get 2 squared minus 5 times of 2 plus 6 equal to 0 equal to, let's see what I get when I substitute in the left hand side. Then this is clearly 4 minus 10 plus 6, which is 10 minus 10 and 0. But because I get this equation to be 0 when I substitute x equal to 2, therefore I say is the root or solution or 0 of the given quadratic equation, is the root of the quadratic equation, this equal to 0 is how I understand the solution. But when I take x equal to 1, let's continue with this, which gives me 1 squared minus 5 times of 1 plus 6, and let's see if I get this equal to 0. This is 1 minus 5 plus 6 minus 4 is 2, which is not equal to 0. Therefore, x is equal to 1 is not the solution of this quadratic equation, is how I conclude. Is not the solution of x squared minus 5x plus 6 equal to 0, is how I understand between the solution and not the solution. So solution of a quadratic equation using the three different names with its notation.